Hello and good afternoon. Hopefully you can hear me okay. We are live for this afternoon's webinar on the final required practical number 12. If this is the first time you're joining us, do come along, check out the website information, get all of the resources by going along to Dr. Clay's alevelchemistry.com. Quick question. It's now 4 o'clock and we will be starting the webinar in a few minutes time. I'll just give everybody a chance just to log in and come along to the site. Okay, so if you've not been to the website before, I'll give you a quick glance around. We're going to start in a couple of minutes on chromatography. That's the final required practical number 12 in just a few minutes time. So here we are. We are live from Dr. Clay's A-Level Chemistry site. You can find the web address here, drclays-alevelchemistry.com. Follow the homepage, and we've got live revision webinars. And we're also today in the required practical webinars. We've been looking over the past few weeks at the required practical skills that you need for your exam. If you come along to the Dr. Clay's quick question, you'll find the YouTube link. You'll also find the resources here. This is a OneNote resource where you'll see all of the work done in just a couple of minutes, which also has all of the previous webinars. I'll open that up so we can see it in just a moment's time. And you'll also find a relevant couple of past paper questions. As well as that, you'll also find the chat room as we're going through the session. What I'd request is that you don't use the chat room here on the left-hand side or the bottom of the screen. Do come along and use the blue chat room. Simply, it makes my life a little bit easier while I'm conducting the webinar. Thank you for your support on that. So just to show you the resources that we've been using so far, if you click the OneNote resource, what you'll come along and you'll find all of the practicals. That's 1, 2, 3, 7, 4, 11, 12, 8, 9, 5, 6, and 10. They're ordered in that slightly confusing way, simply because that's how they sort of sit together. Today's one that we'll be looking at here is practical number 12, where we're going to be looking at our thin layer chromatography. We'll be looking at that in a minute. And there's also some related practical questions which you can look at. And they're also downloadable, those practical questions here. After the webinar, you'll also be able to find the recording and all of the answers in the past webinar section. We've got lots of them here now, going back for a couple of months, covering just about all of the course on the webinar side of things, on our live revision. You'll also find relevant material if you join the site here on the required practical skills, and then all of the relevant topics from the year 2. So if we pop in here, these are all still freely available on my YouTube channel anyway, along with relevant key concept questions. At the bottom, importantly for you guys at the moment, you might be interested in the specimen papers, along with the past paper set 2s, which are now available if you wanted to have a go at those. And we will be looking at the past paper set 2 next week. We did the past paper set 1 just the other week, if you want to check out how that went. Okay, so it's now 4:05. We're going to start the webinar, and we will start having a look at the chromatography, thin layer chromatography, which is the practical 12 from the required practical skills. I see I've got a question here on the sort of drop-down menu. Please do try and keep all of your questions in the blue chat room on the drclays-alevelchemistry.com quick question. All right, so let's have a look here. So just as a point of note, really, This is thin layer chromatography. Really is only going to pop up in your paper too, so it's not truly relevant for next week. But seeing as we've been going through these, we'll have a look this week at the chromatography. So not relevant for your exam on Monday, but certainly is going to be relevant for the exam the following week. If hopefully you've done this many times throughout your chemistry course over the coming years, you may have, or previous years, you may even have met it when you were in biology and other subjects, and it's quite simply a way of separating soluble or solutions. All right, so you probably did it with something like ink. Once upon a time, you might have had black ink, and that would have gone after doing the chromatography. You might have had some different colors of ink go up different distances. So you might have had a red and a blue in there, and you might have compared different ones. The thin layer chromatography, though, is slightly more complex than that idea, and that's what we're going to look at in just a moment as we go through here. So chromatography requires two things. Initially, it requires us to have a mobile phase. So that means something for the molecules or the substance to move through. Importantly, we'll see that this is always a liquid or a gas, and the thin layer chromatography that you'll be doing here is only in the liquid phase. Although you can do gas phase chromatography, that's not a required practical, but is within the requirements of your exam knowledge. But it's unlikely to be asked in terms of understanding the practical necessary. And it also consists of a stationary phase. So a stationary phase is simply a solid, and the stationary phase that we'll be looking at most likely here are going to be silica, which is silicon dioxide, or aluminium oxide. Those are the two key solid phases. And when we do our thin layer chromatography, what you tend to have is you've got a plate, which I'll draw as like this is like a cross section of a plate, and then stuck to the front of that plate would be either your silica or your aluminium oxide, and that is normally white in color. So there we have stuck onto the front of the plate the silica or aluminium oxide. And the key point that we get from this then, as we look to see how the chromatography separates out our samples, is the question of how soluble a substance is versus how well it adsorbs to the surface. So adsorption is how well a substance here, I'll do this in a different color, would go for green. So how well it sticks to the front of the surface. And solubility, so this is attracted to the solid, and versus the solubility. And the solubility is essentially a measure here of how well it dissolves. How well it dissolves, and therefore how well it will pass up and how well it will be pulled through and up the solid. All right, so they're the sort of the key points. What you need to be able to recall, of course, here is the actual practical element. So if we look at our thin layer chromatography here, you're going to have a practical. You could be asked to draw such a practical. The key thing that you need to be able to do is you need to ensure you've got a beaker, and make sure you've got a covered beaker of some description, often using a watch glass. The other thing that we've got here is we've got a solvent, and this solvent, importantly as well, sits below the line of the solvent. If the solvent is the solvent sits below the line of the mixture. So we spot a sample of the mixture onto a pencil line, okay, and that uses a pencil line as the baseline, because a pencil, importantly, is going to be insoluble, and therefore it's not going to get dragged up by the solvent. The solvent sits below that pencil line, and that stops any of your substance essentially just dissolving into the solvent. All right, then you leave the sample to run for a period of time until you get to this thing at some point later where you mark on the solvent front, and the solvent front is the distance the solvent moves. And that's important when we come and look at this thing, the retention factor, in a couple of minutes. What you then have is some spots, if we've managed to separate out our sample, and they will have moved different distances, perhaps that distance, and perhaps this distance. And in this case, we've got 3, so we've got a third distance that it moves. And from these values, we can calculate the retention factor. Like I say, we'll come back to that in just a moment's time. When we're doing this particular thin layer chromatography, as I've said before, our stationary phase is going to be either silica for thin layer chromatography, which is SiO2, or aluminium oxide. Either of those are suitable answers. And the mobile phase, well, this is something that you normally test for. Often a polar solvent, so perhaps something like ethanol. But importantly, it might be something that you want to do a preliminary experiment on to ensure a good separation of spots. So you might do a thin layer chromatography several times with different samples, and you might do different ratios of different solvents in order to identify one that separates the spots well and that they're easily identifiable. Okay. So I'm not going to read through all of the steps here, because hopefully if you pause the video at a later point, you'll be able to read through those at your own time. Once you've seen that the solvent front reaches nearly the top of the line here, you're going to pull the sample out, and you're going to leave that sample to dry. And so you're going to leave it to dry, and once you've done that, you're going to need to expose the chromatogram. This is important. So revise 8 hours a day. I'll come back to you in just a moment, and to your question. Just talking about here, the exposing of the chromatogram. Normally you would do this on something like an amino acid, which means that an amino acid as a spot is invisible, and that means you need to come up with a way of being able to expose and show up, in other words, the spots. There's a couple of ways of doing this. You can use UV light if it's sensitive to UV light, or you can use potentially ninhydrin and then gently warm, or the final option, sometimes you can use iodine to show up the spots. Now, each of these are separate. You don't do them all at the same time, so that is essentially a 1, a 2, or a 3, not 1, 2, and 3. Because if you did all 3 of those, essentially you would get a bit of a mess. So you either use UV light, you either use ninhydrin and warm, or iodine to show up the spots, and that exposes the amino acids. What I didn't mention here is somewhere along here we should have, and if it's not, you always want to wear gloves when you're doing this experiment. Certainly if you're using something like amino acids, you want to wear gloves, because if you touch the thin layer chromatography plate, what you would tend to find is you would add in impurities from your fingers, and you'd end up showing up amino acids and proteins and things like that which are on your fingers, which you don't want to do. So when you're doing the chromatography, ensure that you wear gloves. The final thing before I come back to the question from revision 8 hours is this thing, the retention factor. So the retention factor here, RF, is a unique value for a substance in a given solvent, and it's taken by the distance moved by the spot from the baseline by the distance moved by the solvent. In other words, this value is always going to be less than 1. and it's also always going to be greater than 0, and it is going to be unique for a given amino acid or substance in a unique solvent. Okay, I'll just have a quick look here at the question. Hello, do you know which of the 3 papers, new AQA, this will be part of? Yes, and Kay, you've actually answered the question there. This practical, well, it's definitely, it won't be in paper 1 because paper 1 is inorganic and physical. This is an organic practical, so it could come up in your paper 2, or it could come up in your paper 3. The paper 3 is more practical based, so it's probably the questions that we will look at in just a moment's time come from your paper 3 example, but it could be there seen a week on Monday whenever your exam is. I can't quite remember offhand, but certainly not in your paper 1. There's lots to remember. I completely agree. Okay, so let's have a quick look at a couple of exemplar questions that you could get asked associated with your chromatography. Like I say, these are from paper 3s, and they're paper 3 in style. If we look at this question, a lot of it looks like the way the percentages are laid out that you're likely to get more practical based questions in your paper 3. But it says wearing plastic gloves to hold a TLC plate, draw a pencil line 1.5 centimeters from the bottom of the plate, use a capillary tube to apply a very small drop of the solution of amino acids to the midpoint of the pencil line, allow the spot to dry completely in the developing tank, add the developing solution to a depth of not more than 1 centimeter, place your TLC plate in the developing tank, allow the developing solvent to rise up to the top of the plate, remove the plate and quickly make the position of the solvent, mark the position of the solvent with a pencil, and allow the plate to dry in a fume cupboard. Parts of this procedure are in bold text. For each of these parts, consider whether it's essential and justify your answer. So here, as we look, we've got the first one here, wearing plastic gloves. Well, I think I just alluded to, that is essential. So this was, I think, a 6-mark question. And essentially, was it 6 marks? No, sorry, 4 marks. To identify whether or not it's essential or not, we've got to give an answer for each of these 4 points. Wearing plastic gloves is essential, and that's going to prevent contamination like we've just indicated. So 1 mark for each correct point here, and you've got to think about each one. A depth of not more than 1 centimeter. Okay, so that is, again, essential, because if you went greater than 1 centimeter, your solution, or your substance would dissolve into the solvent, and you wouldn't be able to see any of the substance, and it wouldn't go up the TLC plate. Allow the developing solvent to rise up to the top. Okay, so the rising to the top, that is not essential. All right, what is important for the not for the assessment, but for the practical, is that you need to be able to calculate, or there needs to be enough separation to calculate the RF, or the retention factor. That's the key about that. It doesn't have to go all the way to the top, and indeed you probably want it to go not quite to the top. All right, and then finally, allow the plate to dry in a fume cupboard. Well, I'm just looking for any information. Really, this is sort of going to depend on the solvent that they suggest. So in this particular one, they don't tell us what solvent it is, but what we're going to assume here is that a fume cupboard is certainly a good idea, and basically if we got a toxic solvent, then this is going to be an essential tech, and it's always a good idea, certainly, to use, where sensible, a fume cupboard, given the solvents is going to stop you inhaling it. Okay, outline the steps needed to locate the positions of the amino acids on the TLC plate and to determine the RF values. So there we got two options. Remember I said 1, 2, or 3, so you can spray with a developing agent. You could call it a developing agent or ninhydrin, and warm, or you could just call it developing agent. The key here is it's an or UV light. It's not and UV light. So or UV. If you go for and, you're essentially indicating that you don't quite know what you're talking about. So it's or UV light, and then you need to describe that you would measure the distance of the spots that we just talked about and divide that by measuring the distance of the solvent front, and that your RF value is then going to be, if I label this one X and this one Y, that RF is X over Y. So you describe that you measure this, the distance moved by the spot from the baseline, and measure the distance of the solvent front from the baseline. The final thing here, explain why different amino acids have different RF values. Well, this final one here is going to be associated here with the fact that different amino acids, so if we remember what an amino acid is, so they all have this grouping, but this group here is different, and therefore all amino acids have a different polarity is important description here, and therefore they're going to have a different solubility, which is what we were just talking about, and also a different ability or to absorb, different solubility or adhesion to the silicon dioxide or aluminium oxide, and therefore a different RF. Okay, I've just seen a couple of questions pop through. What I'll do is at the end of this session, I'll put the answers to the rest of the practical questions up online. I'll have a quick look and see what questions we've got. Okay, so the question here, a nice question with fluorescent dye. Let's just see here. I'm just going to add in a question. Here is the first question about, finally, in the previous question, how to determine the RF value. It says, do you need to use ninhydrin and UV light? Okay, firstly, it's or UV light is the key thing that we're looking at here. And a fluorescent dye, it's going to help. What I would go for is if your amino acids are able to fluoresce, then I would use UV light. Otherwise, I would use ninhydrin. The key is that you're not using both of those. And on 4772, your question here, can you give a breakdown of which practicals will be tested on in each paper? What I would say there, Anon, practicals will be tested on in each paper. That information is essentially it's sort of broken down. So practical 1 and 2 here, titration enthalpy, that could be paper 1 or paper 3. It's those which are basically going to be inorganic or physical. The rates of reaction, I'd have to double check. Practical 8 and 9 here. This is practical 8 and 9 where you've got pH and electropotentials. Those are going to be in your inorganic paper and paper 3. So paper 1 and paper 3. 5, 6 and 10. And these are all organic chemistry. So they could be your paper 3 or paper 2. Practical 4 and 11. These are test tube reactions. These are paper 1 and possibly paper 3. And finally, practical 12 here, which is looking at chromatography, is going to be either paper 2 or paper 3. If you want to get information about what's in each of the exams, that sort of thing. It's available in what's in the A-level exams, 3 A-level exam papers. It's one of those resources for our subscribers. The syllabus, all I've done is I put it in slightly, just broken it down for you, and it's there for you if you want, for all of our members. But like I say, it's simply information taken from your A-level syllabus, which is available to everyone. All right, I'm going to bring the webinar to an end. Once again, if you haven't been to the site before, do come along and check out the A-level chemistry revision site. There's lots of resources for our members. We've got the rest of our webinars, which will be continuing throughout the exams. Tomorrow night we'll be looking at essentially reviewing all of the physical chemistry for the paper. Sorry, all of the inorganic chemistry for the paper 1 on Monday, and we'll be doing that by looking at multiple choice questions. Of course, multiple choice questions are not an exam. Next week's webinars, we'll be looking at the unseen set of paper 2 ahead of the organic paper. I'll be online for a couple of minutes. If you've got any further questions, please feel free to drop me a line, and I shall be uploading this tutorial webinar along with the answers to the past webinar section in the next couple of minutes. Thanks a lot for watching, guys, and I look forward to hearing from you soon. Take care.